Alright, and welcome to trigonometry. Now, what is trigonometry? Well, we have three things that are called trigonometric functions. Okay, and let's see what those functions are first. We have sine theta, which is going to be the opposite over the hypotenuse. We have cosine theta, which is going to be the adjacent over the hypotenuse. And we have, we have tangent theta, which is going to be the opposite over the adjacent. So those are trigonometric functions, but what is trigonometry? Well, trigonometry is something that we can utilize when we are given an angle and a side, and we are trying to find another missing angle or another missing side. Okay, so it's very useful when only given these two types of information, and it only works when we're dealing with right triangles. So I should tell you guys that that is a right triangle as well. Okay, so how do we do something like this? Well, step number one, kind of like our last video, we always draw our line through the right angle box, and we know that that always points to our hypotenuse. We then circle the angle, and we know that the other side that's not the hypotenuse must be the adjacent. And then, of course, the side across from that angle is going to be our opposite. So if you always fill in the opposite last, well, then by default, whatever's not labeled must be the opposite. Now from there, we're always going to say this: which two pieces or which two sides have information? So for instance, that has information, it has a number. That has information, it has a variable. But check it out, the adjacent side, there's no number or variable. It has no useful information. So what does this mean? It means we want to go find which one of these three functions has the hypotenuse and the opposite. Wait a second, here's the hypotenuse and here's the opposite. So we want to use the sine theta. Okay, so how do we set up sine theta? Well, we're going to write sine, and theta represents the angle. So our angle from here was going to be that 38.4. And we're going to set that equal to the opposite, which was our x value, over the adjacent, which was that 5. And I should have done the x in purple as well. Yeah, so let me just go over that one right there. Okay. Now, how do you solve something like this? Well, think about it this way. A fraction bar means to divide. So what is the opposite of division? Well, that would of course be multiplication. So to get rid of divided by 5, we're going to multiply both sides by 5. We're going to multiply both sides by 5. Now, this means we now have 5 times sine of 38.4 is equal to x. And we're actually going to have to go to our fancy calculator, and we're going to have to go to our fancy calculator to figure out what that is. Okay, so y'all can see I'm here in Desmos.com Scientific, and I kind of had to shrink it down a little bit, but we're going to do 5 times, and remember our trigonometric function was sine, so the abbreviation for sine is sin, S-I-N. And then, of course, we type in our angle, which is that 38.4. And, of course, I go click here the answer button. Oh, I'm sorry. Let me close my parentheses first. And we'll click the answer button. Oh, you know, I think I had it, and I think that that messed it up. Here, let's go ahead and delete that. Okay, and here's our answer. 3.1057. Now I'm going to round that to 3.11. I'm going to take that 0 and round it up to a 1. And so let's see what that looks like. 3.11. Okay, as we'll say, x is equal to 3.11. Alright, so notice our missing side here is 3.11. There's our missing side, x. Okay, also if you wanted to find this side now, you could actually use the Pythagorean theorem now that you have any two sides, or you could have used another function. Now let's move on to our second example. Okay, here we have example 2. What is the value of x in the triangle below? Okay, so let's start by labeling. Now, firstly, guys, I have to give y'all that this is a right triangle. So let's say it is. I'm drawing my arrow through there, and I know that that points to my hypotenuse. Okay. I also circle our given angle, which is that 48, and I know that this 31.4 must be my adjacent. And of course, our last side to always label will be the opposite. Okay. Well, now we want to figure out which two sides have information. I see that my hypotenuse has the value x. I see that my adjacent side has that 31.4, but there's really nothing over here of interest for the opposite side. Now I'm going to give y'all a little saying to help you memorize these. So here's our saying. So that's SOH, CAH TOA, TOA, SOH CAH TOA. And if you can memorize this phrase, SOH CAH TOA, well, you'll always know our functions. So is sine theta, so there's the S for SOH, and opposite over hypotenuse. So SOH. So, what about CAH? That's going to be cosine theta, there's our C, is equal to the adjacent over the hypotenuse. So CAH CAH. And what about TOA? Well, that's going to be tangent theta is equal to the opposite over the adjacent. TOA. TOA. So if you remember this phrase, SOH CAH TOA, well, you'll have all these functions at your disposal at any time. Okay, so what function are we going to use here? Well, if you will recall, we have our adjacent side, we have our hypotenuse, which we're trying to find, and we see that that is here, it's the cosine theta, where we have our adjacent and our hypotenuse. Now let's go ahead and fill these things in. Now let's say, all right, well, you know our cosine is going to be 48 degrees. Remember, theta is always our angle, is equal to the adjacent side, which goes on top, which will be the 31.4 over our hypotenuse, which is x. And you're going to notice something different here. You're going to notice that here the variable is in the denominator rather than in the numerator. Now this is the one example that really confuses students. But let's begin the same way as always. We always start by multiplying by the denominator. So we multiply both sides by x. Multiply both sides by x. Okay, well now I have x cosine parentheses 48 is equal to 31.4, and those cancel out. So what do we do here? Well, we are going to divide both sides. I'm sorry, let me use a different color. We're going to divide both sides by this cosine of 48. We'll divide both sides by this cosine of 48. And so that completely cancels out. So what does this look like now? Now it looks like x equals, and just kind of keeping the colors consistent here, 31.4 over cosine of 48. So a little shortcut, if you would like, is to know that whenever x is in the denominator, well, simply the x and the tangent function, or I'm sorry, the trigonometric function, those will flip-flop. But, and you'll see that 31.4 stays in the same position. However, we don't really like to use shortcuts in math. We just like to understand how this function is working. Okay, so let's go to our calculator and let's go ahead and plug this in. So it's 31.4. Let's clear this out. So we got 31.4 divided by, and here we can go ahead and put our cosine of 48 degrees, close that off, and you'll see here that our answer is 46.93. I'll say that one more time. Our answer is 46.93 once I round that 2 up. By the way, one thing here, guys, see this little slider, degrees and rad? You always want degrees showing in order to see what the correct answer is. If you click rad, it will give us some weird, goofy answer. So we want it in degrees. Okay. Alright, so the answer was 46.92, and so x equals 46.92. And this should make sense because, guys, remember the hypotenuse is always the longer side. So it should make sense that it would definitely be longer than our adjacent. Okay, let's move on to one final example. Okay, example number 3. What is the length of A in the triangle below? So what is that length right there? All right, well, a couple things. First, I have to give you all that this is a right triangle. I draw my arrow through. There's our hypotenuse. I circle this side. I know that A is also the adjacent. Oh, funny how that worked out. And this must, of course, be the opposite side. Now notice, when we're looking for the two sides that have information, I see that my opposite and adjacent has a number and a variable. However, my hypotenuse is not there. Okay, so we're looking for something that has an O and an A, an opposite and an adjacent. So guys, if I write out SOH CAH TOA, well, I know that opposite and adjacent, that's going to be this TOA. There's no O or A. There's no O or A there. So we're going to use our tangent theta is equal to the opposite over the adjacent. So what's that going to look like? Well, I write tangent theta, which is my angle is 21.8, is equal to, and I see here that my opposite side is what we labeled as 518, all over our adjacent side, which we're going to have to label A, and now we have to solve for A. Now remember, if you wanted to use the shortcut like at a certain point when you truly feel like these, remember your trigonometric function and your variable will switch, they'll flip-flop places whenever you have a variable in the denominator. However, let's work this out the standard way. The opposite of division is multiplication, so I multiply both sides by A, and what I do to the right, of course, I do to the left. So I write this, I write A tangent 21.8 is equal to 518, because those cross out. And now, if you will recall, I now want to divide both sides by my trigonometric function, so I'll divide by 218, or by the tangent of 218, divide by the whole thing, and now we get this. A is equal to 518 over the tangent of 21.8. And it'd probably help if I put those decimals in there so I don't make a silly mistake. Okay, so 518 over the tangent of 21.8. Okay, let's go to our calculator. 518 divided by the tangent of 21.8, and close my parentheses there, and we see our answer will be 1295.09. So 1295.09. So let's say this, A is equal to 1295.09. And of course there's no labels given here, so you'd probably just label it units. Okay, I hope this helps, and I'll catch y'all in our next video.